Two things today. These are the last couple of ways we can solve quadratic equations. One of which is new to you, called completing the square. Completing the square looks really, really weird for something that is really, really easy. And then obviously quadratic formula and discriminant. The only thing that's going to be new there is what's called discriminant. What that is going to allow you to do. I know that all of you guys have worked with quadratic formula before, so that takes like 30 seconds to talk about. Completing the square. Completing the square is another method to solve a quadratic equation. It allows us to solve an equation by turning it into a perfect square. Because what you guys saw over the past couple of days is problems that looked like this. And you knew what to do then. You take the square root of both sides and you would add 3, correct? So what we're going to do is we're going to take a simple quadratic and we're going to turn it into that problem. Because every one of these problems, they can be solved really, really quickly. Rather rapidly, I think would be the right way to say that. Shimp, you don't look so sad. All right, so this is called a perfect square trinomial. It's jump squared. Okay, so it'll be jump times jump. What we're able to do with these equations is to manipulate them enough in such a way to create that. That's why we call it completing the square. Let me show you how this works. Let's use this example here. X squared minus 4x plus 9 equals 0. There are a couple very simple steps to do this process. Every single problem is the same setup. The first thing you do is move C. How do I move the 9? Subtract. Very good. I want you guys to get in the habit of doing this step then. X squared minus 4x plus blank equals negative 9 plus blank. I am forcing you to take a little bit of space on your paper by putting those blanks in to actually show how completing the square works. It is very simple. Okay? First thing we did. What's half of negative 4? Negative 2. Now that I figured out what half of b is, I write that down here. X minus 2. Square it. What's negative 2 squared? 4. I'm going to add that to both sides. Because if I add the same thing to both sides of an equation, does that equation change? Nope. Nope. All I'm doing is just finding some funky way of doing it. Because now take a look at what I did. What times what's positive 4, I add together to get negative 4. Negative 2 and negative 2. I created a perfect square trinomial.
Yay!
Yay! Now, here's the hard part. Negative 9 plus 4.
Probably 27.
I have negative 5 now. Now isn't that a problem where I can solve real quick? How do you get rid of, how do you move it? Square root it and add 2, right?
Yes.
So x is going to equal 2 plus or minus I root 5. That's it.
Whoa.
You're done. Yes, sir. No, because all we're doing here is, since we know that there's imaginary numbers, it's just allowing us to solve any quadratic. We can find the...
I really don't like this.
Correct. We're finding the imaginary number. In this case, it was an imaginary. Sometimes it'll be a positive. It'll be a real number. Yes, ma'am. What I did here, this part here, or this one?
Yeah, that
Okay. When I square it, that's what I'm adding to both sides. Half of b is the negative 2. I dropped it into here. When I square negative 2, I put 4 to both sides. It keeps it balanced. Sir?
So if we forgot to put the plus minus in front of the square roots,
That's bad.
on our homework on Friday.
I will give you a big giant frowny face, but you do that on a test or a quiz, you get points.
Okay.
Okay? So let's look at another one. Oh, that's right. We don't need to look at all these extra parts. Oops.
Oh no.
X squared plus 10x minus 3. Basically, it's asking you what times what is negative 3 that add together to get 10. A whole lot of nothing. So, we're going to complete the square to solve this. What's your first step? Move the 3. So I have x squared plus 10x plus blank equals 3 plus blank. Okay. Now my b value is positive. So what's half of 10?
5.
What goes in parentheses? X plus 5. I square it, and what's 5 squared? I add it to both sides. For those of you guys that do horizontal math, you have to stop doing horizontal math now. Vertical math makes sense, because you can move up and down to set your stuff up. I know a lot of you guys do horizontal stuff because they go, that's saving paper. Please. 3 plus 25. 28. Now what do you do? Square root it. So you square root it. So we have x plus 5 equals plus or minus 2 root 7. I knew it was 2 root 7 right off the top of my head because 4 times 7 was 28.
Wait.
What? And now what? Bring the 5 over. X equals negative 5 plus or minus 2 root 7. Was there do you take a root of a negative? Nope. Sometimes you're going to get a root of a negative, sometimes you won't. Okay? It's just, it depends upon the problem. Yeah, Shiki.
So we use this when we can't factor it, or we can use this any time?
You can use this whenever you want. If it says, unless it says,
Specific methods.
Correct.
on the test.
correct. If it says use quadratic formula, I expect to use quadratic formula. If it says solve by factoring, I expect you to factor. But if it says solve by any means, completing the square, and like you said, this also works for factorable trinomials. It doesn't have to be an unfactorable trinomial. It will still work. It'll give you, 3 plus or minus 2. So you'd have 5 and 1 for your zeros. I mean, it works. All right, it works out just fine. Let's do another one. Got to erase all this. Save the wrong file. X squared minus 16x plus 76 is 0. What's your first step? Very good. Subtract the 76. So we have x squared minus 16x plus blank equals negative 76 plus blank. Do you guys see why I'm telling you to put that plus blank in now? It forces you to remember that you're adding something to both sides of the equation. It's just a little step that will help, hopefully, not allow you to screw up. You could screw up, but hopefully won't. So, half of negative 16. Where does that negative 8 go? Ah, no. It goes in the parentheses. What goes in the blanks then? What is it? Oh, is it negative or positive?
Positive 65.
Positive. Because when we're doing these perfect squares, remember, your last term is always going to be plus. Yes, sir.
The other way. But if there's an n, can't you theoretically calculate 9?
We don't mess with it.
But can you?
There's no reason.
Oh, okay.
So what I'm doing there is I'm creating that perfect square. So now I have negative 76 plus 64 is?
12.
Negative 12.
Negative 12, sorry. I lied to you.
What's that? I heard a wait.
Wait, there's more.
No, what do you got?
Why is there the x minus 8 squared?
The quantity square?
Yes.
What I'm doing is I'm creating, this is called a perfect square trinomial. What times what's positive 64 to add together to get negative 16? Well, it's x minus 8, which therefore creates x minus 8 quantities squared. Okay? What I'm doing is I'm creating that by moving stuff around, by keeping everything balanced. Yes?
Space on down. But x minus 8 squared is not x minus 8 times x plus 8?
No.
Oh, it's different.
The x minus 8 quantity squared, remember, that's junk squared is junk times junk. It has no changes of signs. What you were doing was x squared minus 64 and factoring that. In this case, there is a middle term. Okay? You were doing difference of squares. So lastly then, when I move that when I move this around, we're going to get what? X equals 8 plus or minus, what's the square root of negative 12? Thank you.
I had the odds and say it.
2i root 3. Okay? Do you agree that it is ridiculously simple for something that looks complex? Yes, sir.
How did you get negative 12?
What's negative 76 plus 64? Yes, ma'am. Yeah.
Where's this 8 come
Yeah.
from?
Yep, this is just another method, a means for solving quadratics. We'll talk about it in a minute. What's nice about, yes, sir.
Wait, where does the 8 come from?
I square root both sides, so it was x minus 8. I just moved the 8 over.
Oh, yeah, you have to.
See that? I
see. You have to
just
add it.
skipped a step. What's nice about this is that we use this a ton after we finish up chapter 5. We go to chapter 10. Chapter 10 is conics. And in conics, you complete the square for the to get the equations and stuff all the time, to get perfect squares. This method is like a lifeblood of that whole unit. Being able to complete the square efficiently is very, very, very helpful. Okay. Notice two things that I haven't done yet. First thing is my leading term coefficient has always been what? 1. It's always been 1. What happens if it's not? You guys are, what are you worried about? Seriously, what are you guys worried about?
Sir.
What are you going to do? What are you going to do if you have this?
Math.
You wait till tomorrow to ask you.
Nope.
Oh, you can factor out the 3.
Exactly. No matter what, guys, no matter what, when your leading term coefficient is not 1, divide everything by the leading term coefficient. You may or may not get something that is GCF'd. You may or may not have to deal with a fraction.
You might just get a ton of garbage.
You might get garbage, but the process still works. Here I divide everything by 3 and I get x squared minus 2x plus 4 is 0. Finish it. Take a second and finish it. What I did here is that when we take the half of b, I square it. Negative 1 squared is 1, so I'm adding 1 to both sides. That's what you add. Yeah, JC.
I did my math wrong.
Always change the negative to a positive.
Yeah. Yep. That's me.
If you factor out the 3, does that not make any difference?
What do you mean?
Since it was the GCF. So you just like.
Oh, no, it's, you have, oh, what do you mean, like taking out the 3 like that? Yeah, there's no difference in there, because you're able to, because it's equal to 0.
So you don't have to like write it in.
No, not at all. Because what, in essence, what you've done is that this whole thing was multiplied by 3, so then I divide it out, and it's gone, okay? In pure essence, that's what I did, okay? Yeah.
What if there isn't a grace point factor and just get a bunch of fractions?
Then it just becomes more difficult with fractions, that's all. We'll do that eventually. No. Yes?
So just whenever you have a negative, you're going to just take out the I and like put the I in front of it.
Yep. That's it.
Okay.
You just take an I out and then you simplify the radical like you would normally.
Okay.
All right, and we will do the fraction ones. We will. Don't worry. We're just starting.
Wait, I have another question. So like if you simplify it and then like you know how like you can get the part that you take out, do you put that like the number in front of the I, or
Yeah.
does the I go first?
Yeah, if it was, like we did that, it was the negative 12.
Yeah.
So it becomes, we had it as 2I root 3. That's the proper way of writing it.
Okay.
Okay? So let me show you the other stuff we're looking at today. Quadratic formula.
Yay!
I know for certain every one of you guys have seen this before. In fact, formula is a very efficient way to solve quadratic equations, especially if your leading term coefficients are not 1. Non-factorable ones. It's just a real fast way of doing it. You're just plucking coefficients and going. What's going to be a little bit new for us today is what's called the discriminant. The discriminant is this part. That's the discriminant. What's nice about the discriminant, and this is one of the things you'll see on, bless you, that you'll see on the ACT, is that it'll ask you what type and number of solutions something will have. The discriminant tells you that without going through the whole process. Remember when you guys did the quadratic formula before, if you had a negative for the square root, you just said no answer, no solution? Yep. Now you know if you have a negative root, that means you have an imaginary solution.
Yay.
So you have 3 things that can happen. If the discriminant is, if it's positive, you have 2 real answers, 2 real solutions. So if the discriminant, that b squared minus 4ac, if that winds up being positive, you have 2 real solutions. If it's negative, what is it? No. You have 2 imaginary. Remember you had that plus minus? So you have 2 imaginary. And the only other possible thing that can happen is it could be 0. If it's 0, you have 1 real.
Huh.
And that meant that it landed on the x-axis. It had 1 answer. Your perfect square trinomials have 1 solution. Yes, sir?
I just noticed that you never write things in and then form, or if. Like, was that all hogwash? Did that not really matter?
Oh, if then form?
Yeah.
It's the more precise way of doing it, but to be honest with you, do we need it? Not right now. I could write it out. I mean, if you want me to go through the whole long-winded version of the discriminant, why can't I just say if positive 2 real, if negative 2 imaginary, if 0 1? Right? What you need to know and how you need to know it. I'm like a BS filter. That was weird. So look at an example. If I have this, 2x squared plus x equals 5, and I just want to know the discriminant. I want to know what type of solution. So I'm not going to solve it. I just want to know. The question will ask you, what are the type and how many solutions. So what happens here is that you do have to get it into the standard form, you know, ax squared bx plus c, which means what do you have to move? Yeah. So you have 2x squared plus x minus 5 is 0. One of the things that I will say that it doesn't hurt to do, a is 2, b is 1, c is negative 5. Sometimes it's helpful to label it out so you don't accidentally put the wrong thing in. And now it's just a matter of using the discriminant. B squared minus 4ac. Sorry. So you have 1 squared minus 4 times 2 times negative 5. What's 1 squared? 1. Here we have negative 10 times negative 4 is? Positive 40. So it's 41. So how many and of what type of solution do you have? 2 real solutions. That's it. What do you mean, what's the other one?
You said that there are 2.
This is not the solution. Okay, this is not the solution. This just tells you how many you're going to have. You're going to have 2 real when you're done.
How is that?
The whole quadratic formula would tell you that. If you go back to the whole quadratic formula, opposite of b plus or minus square root
When you
b
finally
squared
start
minus
using
4ac over 2a. If you go back and do the whole thing, you know the opposite of b would be -1 plus or minus the square root of 41 all over 2 times 2. So your answer would have been -1 plus or minus root 41 over 4. Those would have been your 2 real solutions. They're just crummy numbers. That's all. That's all it is. This thing underneath the radical is called the discriminant. It tells you type and how many. That's it. It's ridiculously easy to use. It's not the solution, it's just how many you're going to have. Okay? Question. Sorry I want to be longer than I thought I was going to be here, but oh well. I want you guys to do these. These are all odd problems tonight. There's 2 sections. This is 5-5, and this is 5-6.
Go them on different papers.
You just put them all together, it's fine. It's completing the square, and it's using discriminant and quadratic formula. It's some practice stuff, okay? Yes, ma'am?
So
All of them are odds, yes, except for 88, correct. Everything is an odd number except for 88 for all of the entire assignment. That way you can check your work, okay? I try not to get a little nutty in here. Remember, to use the completing the square, your first term has to be 1. So you have to divide out by whatever that a value is across every term first. There might be a fraction in there. Don't freak out. You know how to work it. Okay?
Schirmer though.
Yeah, that upstairs class is nuts.
They're pretty rowdy.
We're upstairs.
No, there's no classroom up there.
Really? Serious?
Yeah.
Oh, Mr. Murphy.
There's a stairwell go over that way.
it goes down.
No, the one next to it, the other side there, that door that goes up.
Why would Mr. Murphy lie to us?
It's like an imaginary number. It's an imaginary door.
Punch right down for me. That's your job.
I'm sorry, but that's just a lot of problems. And like, I'm really trying to go by.
Wait.
I know, I'm going back, relax. Listen, Mr. Murphy, we have to make a song about this.
Is that just like
It's really shit.
Yeah. It's like 2.5.